So, good evening, everyone. I can see a couple of them who have already joined. So, I think we'll wait for another 2 minutes. Let some more join and then we can continue yesterday's session. I think we can begin. So, yeah, good evening, Disha. Good evening, Sana, Kritika, Avinash. Good evening. Good to see you all again today. So, I think others will join soon. So, we can just pick up from where we left yesterday. So yesterday, the last session, we had discussed the concepts of probability. There, we had just two more concepts pending. We'll first quickly wind that up and then proceed with the next chapter. Okay. So first of all, yesterday, the last concept which we discussed was on conditional probability. So I told you conditional probability can happen only when there are dependent events. If there is independent events, there won't be any conditional probability. Okay. So this was the formula we discussed for conditional probability. We have seen one problem on that as well. Moving on today, let's see what is this joint probability. Joint probability or compound probability is basically something which is derived from conditional probability, which means if there are dependent events, you will have conditional probability. That's when you will have this joint probability. So if the events are dependent events, the joint probability will be probability of A intersection B is equal to probability of A into probability of B slash A, which means if you see here carefully, it is the unconditional probability of one event P of A, where A is what? Unconditional probability here. So it is basically unconditional probability of one event and probability, that is conditional probability of another event. Here P of B slash A means it is the conditional probability of B. That's why we are multiplying conditional probability of one event, which is B, with unconditional probability of another event. Similarly, it can also be unconditional probability of B and conditional probability of A. This is how it works. Got it? Basically, it will be P of A into P of B slash A, P of B into P of A slash B. Okay. This is when there are dependent events. Now I told you when there are dependent events, only then there will be conditional probability, which means if the events are independent events, there won't be conditional probability. In that case, the joint probability will simply be the multiplication of two individual events. So if you have probability of A intersection B, that is the joint probability of A and B, you simply have to multiply probability of A and probability of B. You can see here, both are what? Unconditional probabilities. There is no conditional probability here. Why? Reason because the events are independent events. So, based on this, there are simple questions which come up. Just remember that in any question you see, you have to calculate P of A intersection B. Always remember, if the events are independent events, you can simply multiply those two events, which is P of A into P of B. Okay. So this was about the joint probability or conditional probability. Now, always remember this, I had explained this yesterday also. And will always mean intersection in the set language. And is intersection or is union. Okay. In mathematical terms, we have and is equal to multiplication, or means it is addition. So, or means addition and union, and means multiplication, intersection. This is what you have to remember. Very, very helpful when you are getting stuck in any of the problem. You see there is and, you always remember it is intersection. Whereas if it is or, you should always remember it is union of the two sets. Okay. So this is one more thing to remember. Then yesterday we discussed De Morgan's law. We also discussed in detail probability of A minus B formula. A minus B means it is only A. Only A means probability of occurrence of A as well as non-occurrence of B. This is what we explained this yesterday. And we also solved one question on this where A occurred as well as B and C does not occur. One theory question also we discussed on this. Yes. Now today we will proceed with the next topic. That is on random variable. Now, what is this random variable? Random variable are of two types. One is discrete random variable, one is continuous random variable. So, what is this discrete random variable? So, any random variable which takes discrete values is discrete random variable. The variable, if it takes continuous values, it is continuous random variable. Now, you must be aware what is a discrete value and what is a continuous value. Say, for example, we have this in the statistical description of data chapter, the basics, what do you mean by discrete, what is continuous, etc. Correct? So discrete means, say I'm taking an example, number of students in the class. It can be 80 students, it can be 85 students, it can be 90 students and so on. Correct? There cannot be anything between 80 students and 81 students. Basically, I cannot say there is 80.5 students, there is 80.2 students, not possible. That type of variable is a discrete variable. So if we have discrete random variable, that is basically if you have discrete values, it is a discrete random variable. Now coming to continuous variable. So one more example for continuous variable is height of the students. Okay, some student will have 5.1, some can have 5.2, some can have 5.5 and so on. Which means it can assume continuously as many numbers as it wants. Got it? This is what is continuous variable. Weight of the students, height of the students, etc. So, if the random variable takes continuous values like this, we call it a continuous random variable. Okay. Now, in random variable topic, two important questions they can ask you. One, to calculate E of X. Now, what is this E of X? E of X is nothing but expected value of X, which is basically what we tell arithmetic mean. That is the average. So, average, arithmetic mean, expected value are all one and the same. But in terms of probability, we don't call it arithmetic mean. We don't call it average. Instead, we call it expected value. That's all. So, E of X means expected value of X. And the formula to find the expected value of X is summation EX. Okay. Then second important question is to calculate variance of the random variable. Just like you have expected value, the second question can be to calculate variance. The formula for that is E of x square minus E of x the whole square. Okay. It is also very simple. We can solve one question on this. Just a second. Okay. So now before moving on to the question, I explained you what is discrete random variable, continuous random variable. Now, to calculate the arithmetic mean, I told you expected value of x is nothing but arithmetic mean or average, correct? So if you remember, we used to have what? Frequency distribution, where we had table x and f, correct? We had x values here, we had f values here. What was the formula to calculate x bar? X bar is nothing but arithmetic mean. The formula was summation fx divided by n. Now, what is this n? N is nothing but summation of frequencies, correct? This was the formula. Similarly, instead of frequency distribution, we have probability distribution in this chapter. Probability distribution basically means there will be one variable. Basically, all the x values will be there and their respective probabilities will be there. Okay, this is the respective probabilities. Now, similarly, if we have to calculate the arithmetic mean of this, just like frequency distribution, we have the formula. E of x, the expected value of x will be equal to summation px divided by summation p. Correct? Here we had summation fx divided by summation f. Just like that, we have summation px divided by summation p. But understand, this summation of p, summation of all the probabilities put together will always be 1 because all the probabilities put together is always 1. Correct? So denominator will always be what? 1. And that is the reason we can simply tell E of x is equal to summation x. Got it? This is how we derive this formula. Basically, E of x is simply summation P into x. So multiply probability into x values and go on adding them. That's all. That is summation Px. Okay. We'll solve one question on this. Question, basically example number 15.29. In a business venture, a man can make a profit of rupees 50,000 or incur a loss of rupees 20,000. So he's making profit of 50,000, loss of 20,000. The probabilities of making profit or incurring loss from the past experience are known to be 0.75 and 0.25 respectively. What is his expected profit? Let me repeat the... See, what is important for you all is when you look at the question, you should be able to identify which concept this is based upon. Only then you can straight away solve. Got it? Now, how do you know that this is based upon random variable topic? You can see here what is his expected profit. It means they're asking you expected value of the variable. Understood? This is what is important. What is this? Expected profit. So we'll solve this. So they have given you X values. Basically, is making what? 50,000 rupees profit and 20,000 rupees loss. Correct? So loss is always measured in terms of negative. That is minus 20,000 because it is loss. Then we have their respective probabilities. Probability of profit is 0.75 and probability of loss is 0.25. All we have to do is expected value of X. They have asked expected profit. Expected value is equal to summation P into X. So multiply P into X. That is 50,000 into 0.75, which is 37,500. 20,000 into 0.25, which is minus 5,000. So this will be 37,500 minus 5,000, which is rupees 32,500. This is his expected profit. That's all. Got it? Very, very simple question. What is important is you interpreting that question, that this particular question is based on what concept. Like I told you, understand when you can see expectation, expected profit, etc., which means they are asking you expected value of X. E of X is nothing but summation P into X, which means you will have X values, you will have P values. That's it. Clear? Now next, we have variance of X. You can see here. Variance of X is equal to E of X square minus E of X the whole square. This E of X is nothing but the expected value which we just calculated. Correct? So E of X the whole square. Now what is E of X square formula? See, you can compare. E of X is nothing but summation Px. We are calculating E of X square. So it will be summation Px square. Understanding? I'll repeat. E of X is equal to summation Px. E of X square. In the place of X, we have X square. So the formula will be summation Px square. That's all is the difference. Got it? The formula for V of X is E of X square minus E of X the whole square. Clear? So last one question we will solve based on the expected value, which is actually the combination of, you can see it's actually the combination of combination topic as well as probability, random variable, everything put together. It's a very good question. We'll first read the question. Example number 15.30. Okay, I want you all to interact with me in this question because I want your help in getting the answer. So, a box contains 12 electric lamps, of which 5 are defectives. Okay, so I will write here. So box contains 12 defective, so 12 lamps, out of which 5 are defective, which means 7 is non-defective. Correct? A man selects three lamps at random. So what is R? R is equal to 3. N is equal to 12. R is equal to 3. Now, what is the expected number of defective lamps in this selection? First of all, I told you, when you see this term, expected number, which means they're asking you expected value of X. Correct? That is first thing. Then understand, why do you apply combinations here? Because he's selecting 3 lamps, which means more than one selection is involved. Very, very important. That's when it should strike you that combination concept you should apply. Got it? So he's selecting 3 lamps, which means combinations you should apply. Then expected number means E of X. Okay, we'll proceed now. So first of all, I told you whenever you have combinations, first step is what is N, what is R. Next step is what is total outcomes. Total outcomes is equal to NCR. Okay. Sorry, I think there was some issue. We are back now. So, like I told you, whenever you have to calculate expected value of x, the formula is summation p into x, which means you need to have x values, you need to have p values, correct? So, first we will see what is x, then we will see what is their probabilities. Got it? So, always define x is equal to what is asked in the question. What did they ask you? Expected number of defective lamps. So, they are asking what is the expected number of defective lamps. So, my x will be number of defective lamps. Okay. Now, we have to actually assume which are the different values x can assume. Now, defective lamps can be 0 lamps, correct? There can be 0 defective lamps. So, I start with 0. Can it be -1? -1 defective lamp? Not possible, correct? I start with 0. There can be 1 defective lamp? Yes. There can be 2 defective lamps? Yes. There can be 3 defective lamps? Yes. Can there be 4 defective lamps? No, it is not possible. Why? Because he's selecting only 3 lamps. In that, all 3 at maximum can be defective, which means I have to stop here itself. Maximum defective lamps can be 3. So my values will be 0, 1, 2 and 3. So in the table, I got the x values 0, 1, 2 and 3. Now I have to find their respective probabilities. Got it? Okay, let's do that. Probability where x is equal to 0, which means I want to know the probability where there will be 0 defective lamps. If I am taking 0 defective lamps, which means out of the 3 lamps which I am choosing, 0 is defective, which means all 3 will be non-defective, correct? So all 3 will be non-defective. Out of how many non-defective? 7. So it is 7C3. Understood? So 7C3, please calculate 7 into 6 into 5 divided by 3 into 2 into 1. I told you start with this number which is 7. Multiply 3 times. 7, 6, 5 divided by r factorial which is 3 into 2 into 1. So this is what? This will give you 35. But understand we are calculating probability, which means favorable divided by total. 35 is the favorable divided by total number of outcomes. What is total number of outcomes? 220. So 35 by 220 is the probability. Understanding? Any doubts? People please ask me in the comments. I can solve immediately. Okay. I'm assuming you all are understanding this and proceeding. This is when x is equal to 0, which means 0 defectives. Zero defective means that all three lamps which you have selected are non-defective itself. So 3 non-defective lamps I am selecting out of 7 non-defective. That is 7C3. Clear? Next. Probability where x is equal to 1, which means one defective I am selecting. The rest 2 will be non-defective. So 1 defective out of 5 defective. So it is 5C1 into 2 non-defectives out of 7 non-defectives. So 5C1 into 7C2. Why is it into? Why is it multiplication? Because I want 3 in total. 1 defective, 2 non-defective. So 1 defective and 2 non-defective. Because it is and, I go for multiplication. Here. So solve this. You will get 5 into 7 into 6 divided by 2 into 1. This will be 105 divided by total outcomes, which remains the same, which is 220. Got it? This is the total outcomes. Next, probability where x is equal to 2. So, 2 defectives, which means the balance 1 will be non-defective. So, 5C2 into 7C1, which is equal to 5 into 4 divided by 2 into 1 into 7C1 is equal to 7, which is equal to 70 divided by 220. Finally, probability where x is equal to 3. 3x, which means 3 defective lamps. So all 3 which I am selecting will be defective itself. No, so 0 non-defective, correct? 3 defective out of 5 defective. It is only 5C3, which is 5 into 4 into 3 divided by 3 into 2 into 1, which is equal to 10 divided by 220. So I got the respective probabilities of x also. Understand, I have stopped x only till 3. Reason being, the lamps which I am selecting are only 3. So maximum defective lamps can be 3 itself. I am starting with 0 because there is chance that there are 0 defective lamps. I can't go -1 because -1 defective lamps not possible. So I start with the 3. Sorry, I start with the 0 and I can go maximum up to how many selections I am making, which is 3 in this case. So 0, 1, 2, 3. I got the x values 0, 1, 2, 3. I got their respective probabilities also, which is 35 by 220, 105 by 220, 70 by 220 and 10 by 220. So I've already formed the probability distribution. Now I want to find E of x. E of x is nothing but summation P into x. So multiply 0 into 35 plus by 220 plus, and right here 0 into 35 by 220 plus 1 into 105 by 220 plus 2 into 70 by 220 plus 3 into 10 by 220. Get me the answer. Tell me what is the final answer. This will be the expected value. That's all. Expected number of defective lamps. I want the final answer. See, the denominators are same. So just go on multiplying and then divide by 220. That's all. Understood, everyone? Everyone understanding? If you have any doubts in any of the steps, please ask in the comments. We'll address it immediately. Because see, exams are nearing. You won't get another chance to clear your doubts. It's now or never. 275 by 220, which is 1.25. Very good, Sahana. This is the right answer. 1.25. Did everyone understand how this works? See, always remember, solving the question is not so difficult. Understanding what concept-based question is that is difficult. Once you understand based on what concept, what you should solve, then you can easily start solving. Like I told you, I'll explain this again. First of all, you see that man is selecting 3 lamps, which is more than one selection involved. I told you more than one selection, please go for combinations. So you know that combination concept will apply here. Second, what is the expected number? Whenever you see the term expectation, expected number, please go for random variable concept, that is E of x. This is what they are asking you. E of x formula is summation px, which means I will have x values, I will have p values. So start finding x and p. So what is x? X is always what is asked in the question, which is number of defective lamps. So I'll define x, which is number of defective lamps. Before this, always remember, concept based on combinations will start from n is equal to r is equal to total number of outcomes. So you write what is n, what is r, then total outcomes. Once you calculate total outcomes, next to go for defining what is asked in the question. Then, which are the different values x can assume? Start with the 0. 0 lamps, 1 lamp, 2 lamp, 3 lamp. I'm stopping at 3 because maximum selection is 3 itself. I can't go beyond it. Next, for every value 0, 1, 2 and 3, calculate their respective probabilities. So this is based on combinations. Correct? For example, defective lamps is 0, which means all the 3 which I am selecting will be non-defective only. So 3 non-defective lamps I am selecting out of 7 non-defective lamps. So it is 7C3. Solve what is 7C3? It is 35. But remember, this is probability. So there will always be what? Total number of outcomes. Total number of outcomes is 220 here. Similarly, calculate probabilities for every value of x, right? So this is what you get, probabilities. So you write x values here, probabilities here, multiply them, you get E of x, which is 1.25. This is the expected number of defective lamps as per the question. Okay, you can see here it is 1.25. Clear? So here we can end the chapter of probability. Actually, it's a very interesting chapter. Simply people are, really scared of this chapter, which is not really necessary. Like I told you, at least attempt those questions which are easy questions, which are standard questions. And now after I have taught you how to approach the combination question, expectations questions, please practice them after this session. Okay, you yourself will master in it. So now let's proceed with the next chapter. So far, if you have understood everything, please give me a thumbs up in the chat and we can just take 1 minute break and then move to the next chapter. Okay, so Pratiksha, Sanvi, Disha, Vaishnavi, Sahana. Thank you. Thanks for your thumbs up. What about others? Concepts are unclear, or are you just watching? Nothing is entering. What's happening? Shall we proceed? Okay. Now the next chapter is a theoretical distribution. Now this chapter generally looks difficult in your PU days, correct? As per your PU syllabus, this is a little complicated chapter. However, the questions based on this chapter for your CA foundation is pretty easy. Okay. The questions will be really, really easy. So not to worry, just have to remember the formula for each of the distribution. Now we have three types of distribution in this chapter. One is binomial distribution, Gaussian distribution, and normal distribution. Now you have two types of probability functions. One is probability mass function, one is probability density function. So earlier we discussed there are two types of random variable, correct? One is discrete random variable, another is continuous random variable. Discrete random variable follows probability mass function and continuous variable follows probability density function. Again, this can be asked as a theory question. Discrete random variable follows probability mass function. Continuous random variable follows probability density function. Now coming to the you can see here the first two distributions we are talking about, which is binomial distribution and Poisson distribution. Both these distributions will have discrete random variable. Got it? Both these distributions will be using discrete random variable. And that's why you can see here it's mentioned discrete probability distribution. Yes? Now, first let's come to binomial distribution. Under binomial distribution, the number of trials will be fixed. Fixed number of repeated trials. Okay. The trials will be done at under identical conditions. So these are the basic assumptions under binomial distribution. And only two outcomes will be there in every trial. That is either success or failure. Okay. These are the conditions on which binomial distribution is formed. That is fixed number of repeated trials. Trials are done under identical conditions and every trial will have only two outcomes, which is success or failure. Now, this binomial distribution has two parameters, which is P and N. Basically, we define it as X follows binomial distribution with the parameters N, P. Now, here N is nothing but number of trials, whereas P is nothing but probability of success in one trial. So, in every trial, what is the probability of success? That is P. You can see here, P is probability of success. Now, Q is 1 minus P, which is nothing but probability of failure. Got it? It's basically complementary of success, which is failure. P is equal to probability of success. Q is equal to 1 minus P. That is probability of failure. But we just need two parameters. That is N and P. N stands for number of trials. P stands for probability of success. Because it has exactly two parameters, we call it biparametric distribution. Okay. This is known as biparametric because it has two parameters. Now the formulas are important. Mean is equal to N into P. Variance is equal to N into P into Q. SD is equal to root NPQ because SD is nothing but root of variance. So root N into P into Q. This is very, very important. This is the formula to find binomial distribution. F of X is equal to NCX into P power X Q power N minus X, where X will be taking what values? 0, 1, 2, 3 till N. Now, do you know why is it from 0, 1, 2, 3 till N? Why is it not from -1? Because why do we start only from 0? And you can see there is no points here. It is only 0, 1, 2, 3. Full integers are mentioned. Why? Why is it not 1.5, 2.5? Reason is this will have discrete random variable. Discrete random variable will never take points. Correct? So that's why we only have 0, 1, 2, 3 and so on. And this will go up to n. This is what you have to remember. Got it? Next, how do we find mode here? For calculating mode, first you need to find out the value of n plus 1 into p. If the value of n plus 1 into p is integer, there will be two modes. Okay. What are the two modes? One mode will be n plus 1 into p. The other mode will be n plus 1 into p minus 1. If the given value is not an integer, there will be only one mode. That mode will be integral part of the n plus 1 into p value. Put it this way. We'll have to first find value of n plus 1 into p. This value can be integer or non-integer. Okay, it can be integer or non-integer. If it is integer, you will have two modes. Integer means what? Full number. Correct. For example, 5. This is integer. Let's assume that the value of n plus 1 into p is 5. It's an integer, which means it will have two modes. The modes are n plus 1 into p, n plus 1 into p minus 1. Basically, this will be 5. This will be 5 minus 1, which is equal to 4. Got it? But instead of 5, if the value is 4.5, which is a non-integer. So if the value is 4.5, there will be only one mode, and the mode is nothing but integral part of integer. Integral part of this value. What is the integral part here? The whole number here, 4. So mode is equal to 4. So in 4.5, the integral part is this whole number. It is 4. Understood? This is how you calculate mode. Then, so why do we have Poisson distribution? Understand, Poisson distribution is also an extension of binomial distribution itself. Just that when the number of trials will be so large, when the number of trials are large, we go for Poisson distribution. And along with that, the probability of success must be very small. Probability of success is nothing but p, correct? If the value of p is very small, if n is very large, we go for Poisson distribution. So in any question, you see p is equal to 0.02, etc., which is very, very small. You know that the question is of Poisson distribution. Next, here mean is finite and moderate. Now, which are the parameters Poisson distribution follows? That is m. It only has one parameter, m, which is also known as lambda. Okay, so we can say that x follows Poisson distribution with the parameter m or lambda. Because it has only one parameter, we call it uniparametric distribution. Okay, so here we had n as well as p. So mean is equal to n into p. Instead of n comma p, we have only m here. That's why mean is equal to just m. Variance is also equal to m, whereas standard deviation is equal to m. Okay, this is what you have to remember. Now, coming to the formula. Function of x, f of x is equal to e power minus m, m power x divided by x factorial. This is the formula to find under Poisson distribution. Now, what will be the x values? X values again starts from 0, 0, 1, 2. See, here it went up to n. Now, here what is happening is n is so large that it can go up to infinity. And that's why instead of n, we have infinity here. So 0, 1, 2 can go up to infinity. Got it? Now, sometimes in the question, e to the power minus m value will be given. If it is given, please take that value. If e power minus m is not given, remember the value of e is 2.71828. It's a constant value, 2.71828. You have to by heart this. Okay. So see, generally, here m is equal to n into p. That's why instead of np, we have m here. That's all. Okay, if we have to find m in the question, which is nothing but n into p itself. Got it? So you can see here, cause an approximation to binomial, which is approximately equal to binomial itself, where n will be so large that it will go up to infinity, and p is very, very small that it can go up to 0. Got it? If n tends to infinity, p tends to 0, Gaussian distribution will be equal to binomial distribution. Here, you can see Gaussian has parameters m, this has parameters n as well as p. So this is about binomial distribution and Gaussian distribution. Now understand both these have discrete random variables, which is why we have only whole numbers here, 0, 1, 2, 3 and so on. There is no pointer values here. Got it? Because both are discrete random variables. Moving on. Next is normal distribution. Now, normal distribution will have a continuous random variable as the value. You can see here, this is a continuous probability distribution, which means it will follow continuous random variable. So, this is the formula. F of x is equal to 1 by sigma into root 2 pi e to the power minus x minus mu divided by sigma whole square into 1 by 2. Do you have to by heart this entire formula? I would say no. You need not by heart it like that. All you have to do is just remember where is sigma, where is mu in the formula. That's all. For example, you can see sigma here. You can see mu here. This position you should remember. Very, very important. Because I'll show you one or two questions on this where the question is going to be very, very simple. You just have to locate where is mu, where is sigma. That's all. You don't have to by heart the entire formula. We'll solve this question in some time. So, here mean is equal to mu, SD is equal to sigma. The parameters of normal distribution are mu and variance. It is not sigma, it is not standard deviation. It is sigma square, which is variance. Got it? These are the two parameters. Again, because this has two parameters, we refer this to as biparametric distribution. Here. So this normal distribution is a bell-shaped curve. It will be like this. It's a bell-shaped curve. Sorry. Right? In the bell-shaped curve also, you can see the tail will never touch the x-axis. The horizontal axis, tails will never touch. They will extend indefinitely. Okay. Now, this entire area of the normal curve is what? 1. Because it is the area of all the probabilities put together. So, entire area is 1. Now, normal distribution is a symmetric distribution, which means all the points are equidistant from one another. If I divide this in between, both will be equal. This is 0.5 and this will be 0.5. Got it? Because it is a symmetric distribution, so it will be dividing the entire curve equally. Got it? Then, here mean is equal to median is equal to mode, which is nothing but mu itself. So if you calculate the value of mu, that itself is mean, that itself is median, that itself is mode. Reason being, it's a symmetric distribution. Here, next, formula for finding mean deviation here is 4 by 5 sigma, or you can use 0.80 sigma. Quartile deviation is 2 by 3 sigma or 0.675 sigma. Q1 is mu minus 0.6745 sigma. Q3 is mu plus 0.6745 sigma. Now see, some authors use 0.675 sigma, some use 0.6745 sigma. Either of them is okay. Check what options are given, try both. Whatever is giving you the answer, use that. Okay. So this can be 0.6745 sigma. It can be 0.675 sigma also. Next, points of inflection. There are 2 points of inflection. One is mu plus sigma. One is mu minus sigma. Now, the area between mu plus sigma and mu minus sigma will be this. All this area you can remember. It is better to remember so that any question comes directly as a theory question, you can answer. You don't have to waste your time in calculating anything. Got it? So straight away, without thinking, you can answer. So I'll tell you one concept. This is a normal curve. Now in the normal curve, the middle point, the middle value will be what? Mu. The next value, next value, next value. So the first value, this is always 0, which is nothing but mu. Basically 0.0, I'm telling, it will be any value. It can be any value. Okay. This will be mu. The next point will be mu plus sigma. The next point will be mu plus 2 sigma. The next will be mu plus 3 sigma and so on. So sigma will go on getting added. Similarly, here first point will be mu minus sigma. Next will be mu minus 2 sigma. Next will be mu minus 3 sigma and so on. You know that the points can range from minus infinity to plus infinity. Correct? It can go up to infinity. Now, if I know that value of mu is equal to 10, sigma is equal to 5, I can understand that this value is what? 10. This is what? 10 plus 5, 15. This is what? 10 plus 10, 20. Plus 5, 25. Like this. Got it? Here also mu minus sigma, 5. And so on. Understanding? So this will be what? Mu plus sigma, mu plus 2 sigma. But if I want to know any value in between, how will I calculate? I can only calculate this point. I can only calculate this point. Understanding? Just this point and this point. If I want to know any value in between, the area in between this, I should go for something known as Z table. Okay. So value of Z is equal to X minus mu divided by sigma. So once you calculate the value of Z, refer the Z table, which will be given in the question itself in the examination. Z table will be given just like your log table. Against the Z value, whatever you have got here, check what is the value given, that is your answer. Clear? That is the Z table. So this is what? When you use Z table, we call the normal distribution as standard normal distribution. Got it? In that case, always remember, mu will become 0, SD will become 1. Again, if it's asked as a theory-based question, just remember that when Z table is used, we call it standard normal distribution. When standard normal distribution is there, mu will become 0, SD will become 1. That's all you have to remember. So all this you can recalculate taking mu as 0, SD as 1. Not so important. So this we have already learned that it will divide into 2 equal parts. The first half will be 0.5, second half will also be 0.5. This I just explained to you here. How this works. Clear? Clear so far? We'll solve a couple of questions in this and then proceed. So, come to example number 16.2, which is page number 16.5 of the chapter Theoretical Distributions. Let's start. So, if 15 dates are selected at random, what is the probability of getting 2 Sundays? Okay, if 15 dates are selected at random, what is the probability of getting 2 Sundays? So, we will start here. Always remember, x will be equal to what is asked in the question. What have they asked? What is the probability of getting 2 Sundays? So, x will be equal to number of Sundays. Always, first thing you have to do is define x. X will be always what is asked in the question, which is getting 2 Sundays, which means x will be number of Sundays. Now, I want two things. One is P, one is N. What is N here? I am taking 15 dates, which means N is equal to 15. Correct? What is P? P means probability of success in one trial. So, probability of success of getting X in one trial, which means in this case, probability of getting Sundays in 1 week. In 1 week, what is the probability of getting Sundays? Is 1 by 7. Correct? This is how you define. First, you define X, which is asked in the question, number of Sundays. Next, go for P, which means probability of success in one trial. So, probability of getting Sundays in one trial or 1 week, which is nothing but 1 by 7. If P is equal to 1 by 7, Q is equal to 1 minus P, which is 6 by 7. Got it? I got P, I got Q. Now let's substitute the formula. I want to get probability of getting 2 Sundays. So x is equal to 2 I want to calculate. P of x is equal to 2, which is equal to, apply the formula, f of x is equal to ncx p power x q power n minus x. Correct? So n is how much? 15. 15c 2. X is 2. P is 1 by 7 to the power x, which is 2. 6 by 7 to the power 15 minus 2, that is 13. Please solve this and give me the answer. Quick, quick, quick. 15c2 into 1 by 7 to the power 2 into 6 by 7 to the power 13. Get me the answer in points, in decimals. Let's see who is going to get it first. Quick, quick, quick. 15c2 into 1 by 7 to the power 2, 6 by 7 to the power 13. Nobody is getting the answer. Just have to multiply them fast. Okay. 0.2888. This is the answer. Very good. 0.2888. You can round this off as per the options given in the question. Okay. So this is the right answer. 0.2888. Understood everyone? Is it clear? Always remember x will be number of Sundays. Basically what is asked in the question. P means it is the probability of getting X in one trial. So probability of getting Sunday in 1 week, that is 1 by 7. That's all you have to crack. After that, it is pretty simple. Okay. One more question we'll pick up. Next question, which is 16.3. The incidence of occupational disease in an industry is such that the workmen have 10% chance of suffering from it. What is the probability that out of 5 workmen, 3 or more will contract the disease? First of all, they are saying the occupational disease in an industry is such that the workmen have 10% chance of suffering from it, which means that probability is equal to 10%, which is 0.10. Correct? Then out of 5 workmen, which means n is equal to 5. These are the two things which we want. Once you get P, I can calculate Q. Q is equal to 0.90. Correct? So let's solve. They're asking you 3 or more will contract the disease, which means what is asked in the question? 3 or more will contract the disease. X is equal to number of workmen who will contract the disease. Number of workmen who will contract the disease. Correct? So what is asked? 3 or more will contract the disease. They are asking you X is greater than or equal to 3. Yes, 3 or more. So greater than or equal to 3. So if it is greater than or equal to 3 means, if you remember, I told you X will start from what? 0, 1, 2, 3. It will go up to how much? Up to n, which is 5 in this question. So probability of X is equal to 3. That is equal to 3 plus probability of X equals 4 plus probability of X equals 5, because n is 5. I will go up to 5. Got it? Now apply the formula. For each of this, you have to apply this formula. NCX P power X Q power n minus X. So first case will be 5C3 because X equals 3 into P. What is P? 0.10 to the power 3, 0.90 to the power 5 minus 3, which is 2, plus 5C4 into 0.10 to the power 4 into 0.90 to the power 5 minus 4, which is 1, plus 5C5 into 0.10 to the power 5, 0.90 to the power 5 minus 5, which is 0. Calculate this and get me the answer. Understood? Just have to apply formula for all of this. So here greater than or equal to 3 is mentioned. So you start from 3, you go up to n. N is 5. So X is equal to 5. Calculate this, get me the value. What is the answer, guys? 0.00856. Very good. It is 0.00856, which is approximately equal to 0.0086. Yes, good Vivek, good Vaishnavi. Yes, Disha, 0.00855. Very good. Understood? So this is a very simple question. All you have to do is find what is N, what is P. Once you get P, you can calculate Q. And define what is X. X is always what is asked in the question. All these basics, if you understand, any question that comes in the exam, you'll be able to solve. Okay? So one question will solve on mode. Example number 16.9. What is the mode of the distribution for which mean and SDR 10 and root 5 respectively? So mean is given as 10, SD is given as root 5. What is the formula for mean? It is N into P. N into P is 10, whereas SD is given as root 5, which means variance will be equal to root 5 whole square. Root and square will get cancelled. Variance is equal to 5. The formula for variance is what? N into P into Q, which is equal to 5. So this is what we have. Now they are asking you to calculate what is the mode. See, to calculate mode, first you need to find out N plus 1 into P value. Correct? You have N. Do you have P? No. First we'll have to calculate that. N into P is equal to 10. N into P into Q is equal to 5. So can I substitute here? N into P is what? 10. So 10Q is equal to 5. Q is equal to 5 by 10, which is nothing but 1 by 2. If Q is equal to 1 by 2, P also will be equal to 1 by 2, which is 1 minus 1 by 2 is 1 by 2 itself. Got it? So P equals 1 by 2, Q equals 1 by 2. Now, NPQ is equal to 5. Sorry, one second. System. So we got P here. We just need to calculate N now. N into P is equal to 10. That is N into 1 by 2. Substitute the value of P here is equal to 10. N is equal to 10 into 2, which is 20. Now we got N is equal to 20. P is equal to 1 by 2. Calculate the value of N plus 1 into P. What is N? 20 plus 1 into 1 by 2, which is equal to 10.5. Correct? 21 divided by 2, which is equal to 10.5. So this is what? It is a non-integer. If it is non-integer, you will have only one mode. What is the mode? Integral part of the value. Integral part is nothing but 10 here. So mode is equal to 10. Understood? The whole number what is given here before the point will be the integral part, which is 10. So mode is equal to 10. You can see here, mode is equal to 10. Understanding? Copy this. We'll move to the next question. Okay, shall we proceed? We'll move to the next question. Come to 16.15. 16.15. So, between 9 and 10 a.m., the average number of phone calls per minute coming into the switchboard of the company is 4. See, they already said that average number of phone calls. Average number of phone calls means it is already what? Mean is given. Correct? So, what is mean here? M is equal to 4. I told you M is equal to mean is equal to mode. Correct? Basically here mean is equal to 4. That is average is equal to 4. Got it? Now, see, first of all, understand here they have mentioned that average number M is equal to 4. Find the probability that during one particular minute there will be no phone calls. At most 3 phone calls given e to the power minus 4. When you see this e to the power minus 4, you know that you have to apply Poisson distribution formula. In Poisson distribution formula, you have only M here, which is average, which is mean. Mean M is equal to 4. Here, we'll start solving now. M is equal to 4 is known. What is X? X is equal to what is asked in the question, that is, there will be no phone calls, at most 3 phone calls, which means X is equal to number of phone calls. Correct? Now, what have they asked? First of all, there will be no phone calls, which means probability of X is equal to 0 is what they are asking. What is the formula? E to the power minus M, M to the power X divided by X factorial. In this case, E to the power minus 4, 4 to the power 0 divided by 0 factorial. If you see here, e power minus 4 value is already given. So you need not take the constant value again. Just copy this value only, which is equal to 0.018316. 0.018316 into 4 power 0. What is 4 power 0? 1. Divided by 0 factorial is 1. So value is this value itself. The answer is 0.018316. This itself is the answer. Got it, everyone? Understood? Coming to the second part. At most 3 phone calls. At most 3 phone calls means what? It means it is maximum 3 phone calls. Maximum 3 phone calls means it can have less than 3, but maximum should be 3. So I have to find the probability where X is less than or equal to 3. Got it? Less than or equal to 3 means probability where X equals 0 plus probability where X equals 1 plus P of X equals 2 plus P of X equals 3. Why did I start from 0? Why not negative number? Because X is what? Number of phone calls, which can be 0 phone calls, which can be 1 phone call, 2 phone call, 3 phone call. They said maximum should be 3 phone calls. So last here I will write 3. Up to 3 I will write. Correct? Now substitute using the formula. Formula says this e power minus m, m power x, x factorial. Understand? This will always remain the same. Why? Because m will not change, e will not change. What will change is only x. So if you look here, e power minus 4 will be common for all 4 of these. If you want, try this yourself. E power minus 4 will be common. Because m will not change, e will not change. What changes is only x based on these values. So this will be common. What will be inside is m power x divided by x factorial. So m power x by x factorial plus m power x by x factorial plus m power x by x factorial plus m power x by x factorial. Correct? So this is e power minus 4 into 4 power 0 is 1. by 0 factorial is 1 plus 4 power 1 is 1, 4 power 1 is 4 divided by 1, which is 4 plus 4 square is what? 16 divided by 2, that is 8 plus 4 cube divided by 3 factorial. 4 into 4 into 4 is 64 divided by 3 into 2, which is 10.66. Now add this 10.66 plus 8 plus 4 plus 1 into the value which is given, that is 0.018316. You will get 0.43. This is the answer. Anyone has any doubts? Please ask in the comments. We'll discuss immediately. Even if it is a very silly doubt, it's okay, but please ask so that you don't get stuck in the exam. Always define X, which is nothing but what is asked in the question. That is, no phone calls, at most 3 phone calls, which means X is equal to number of phone calls. That is what is asked. Now they said average number of phone calls. So average means mean. So M is equal to 4. Correct? Then first question is saying where there will be no phone calls. So X is equal to 0. Apply the formula. At most 3 phone calls, which means maximum 3, which can be less than 3, but maximum should be 3. So I start from 0, 1, 2 and 3. Apply the formula here. We'll get the answer. Remember, in the formula, this is always common. So you can take it outside. Got it? If you want, try without taking it outside. Then you will realize that e to the power minus 4. Basically, e to the power minus m is common for all of them. Okay? So 0.43 is the answer. Got it, everyone? Done? Can we proceed? We'll move to next question, which is come to page 16. Sorry, question number 16.20. Just one question on normal distribution we will solve. I'll tell you how the question on that big formula will come. You can see here 16.20. This is the question given. For a random variable x, the probability density function is given by this. I told you probability density function is what? Normal distribution. That's when you should realize the question is on normal distribution. Identify the distribution and find its mean and variance. So what is mean? Mean is mu. They're asking what is mu and what is variance. Okay. In the formula we have mu, we have sigma. First we will calculate mu, we will calculate sigma. So I told you all you have to do is just compare with the formula. The formula is what? Fx is equal to 1 divided by sigma into root 2 pi into e power minus x minus mu divided by sigma whole square into 1 by 2. Correct? So this is the formula. Like I told you, all you have to do is just compare the formula and check where is mu, where is sigma. You can see mu here. Correct? In the place of mu, you can see 4. That's all. So mu is equal to 4. That's it you have to do. Just have to compare. Locate in the place of mu what is given. In the place of sigma what is given. Next, always check the sigma which is here. Don't check this one. You will get confused. Okay. Always check the sigma which is given here with this. So here you can see that root pi is equal to sigma into root 2 pi. So sigma is equal to root pi divided by 2 pi. Pi and pi I can cancel. What remains is sigma is equal to root 1 by 2. Yes, but what do I want? Variance, that is sigma square. So sigma square is equal to root 1 by 2 whole square. This will get cancelled. What remains is 1 by 2. So the answer is 4 and 1 by 2. That's all. Understood? It's very, very simple. All you have to do is just to locate in the place of mu what is there, in the place of sigma what is there. Equate them, you will get the answer. In the place of mu there was 4. This you have to just equate. That is root sigma is equal to root pi is equal to sigma into root 2 pi. So sigma is equal to, simplify, you will get the answer, which is 1 by 2. Got it? Understood everyone? This is the question which they can ask based on that lengthy formula. You don't have to by heart entirely. Just have to locate where is mu, where is sigma. That's all. Always locate the mu here. Go for sigma which is given in the denominator. Equate them. That's all. Clear? So rest of the questions are very, very simple based on this chapter. So I think we will wind up this chapter of theoretical distribution. We solved a couple of questions from this chapter. We understood what is the binomial distribution, what is Poisson distribution, and what is normal distribution. In this entire chapter, all you have to remember is one thing: don't ever forget the formula. Without formula, you can't solve the answers. Correct? In the formula, always check what are the parameters asked. For example, for binomial, you want two parameters, which is n and p. If you get p, you will automatically get q as well. Like this, go on solving the questions. Next, always define x first. What is x? X will be what is asked in the question. So that will be your variable x. So this is about the chapter theoretical distribution. We'll take a quick 2 minutes break and proceed with the most easiest chapter, which is index number. Okay, so now let's start with the new chapter, which is actually the most easiest chapter. Whatever you have studied in PU, that's exactly what will be asked in the exam, because it's only purely formula based chapter. Okay, so once you have by hearted the formula, your job is done. The questions are going to be straightforward. So let's not get into solving any much questions in this chapter. We'll quickly brush up the formulas once. Okay. Now index numbers, methods of finding the price index number. There is simple method, there is weighted method. Simple method comprises of simple aggregative method. So formula to find simple aggregative method is P01 is equal to summation of P1 by summation of P0 into 100. Okay. Summation P1. P1 is what? The price of the current year divided by price of the base year. That is summation P0 into 100. Now, simple average of relative method. See, what happens is in simple aggregate method, you are simply adding the current year prices, simply adding the base year prices. Okay. Irrespective of whether the units of measurement of the products are same or not. So this is the simple aggregative method. But simple average of relatives method says the units of measurement becomes irrelevant here. When the products are having different units of measurement, we generally go for this method, which is simple average of relative method. Because for every product, we first calculate the relatives, the price relatives. How do we calculate price relative? It is P1 upon P0 into 100. We first calculate that for every product and then we go for the simple average of price relatives, which is summation P by N. What is P here? P is nothing but P1 upon P0 into 100. Got it? Remember this formula? Next, in weighted, we have weighted aggregative method, weighted average of price relative method. Now, weighted aggregative, there are 5 different formulas, which is your favorite formula, right? Laspier's formula, Paget's method, Marshall-Edgeworth, Dorbish-Bowley, and Fisher's. Out of these 5 methods, we first have to just understand for each method what will be the weights used. For example, also such theory based questions can be asked out of this particular topic. So understand Laspier's formula. Laspier starts with what? L. L means it is last year. Last year means what? It is base year. Correct? So remember here what weights we are using is of base year. Base year quantities is what we use as weights. What is that? I'll repeat. Last year's means it starts from L. L stands for last year. Last year means it is base year. So base year quantities are used as weights. This is what? Very simple. Summation P1 upon summation P0. Basically the price relatives. How do we calculate price relatives? P1 by P0 into 100. Just like that, we have summation P1 by summation P0. Because this method is weighted aggregative method, we have to assign some weights to that. What weights to assign depends upon the method. The first method is what? The base year. So base year quantities are used as weights. That's all if you remember. It will be easy for you to remember what is the formula in the exam. You won't get confused. Okay. Next. Now you can only tell me Paget starts with P. P stands for present year. Present year means it is current year. So current year quantities are used as weights. You can see here. Current year Q1 is used as weights. Current year quantities are used as weights. So this will remain the same. Summation P1 by summation P0. This weights will be Q1, which is current year weights. Got it? Now Marshall-Edgeworth said, I will combine both Laspier's and Paget's. So you can see here it is a combination of Laspier's and Paget's, which means base year quantities are also used as weights. Current year quantities are also used as weights. Basically, it is just combination of both these methods. Got it? That is also, last place is also added, past is also added. This is Marshall Edgeworth. Next, Dormish Bowler said, I will simply do the arithmetic mean of whatever last year's and past year's found out. So you can see here, it is the arithmetic mean of the last year's and past year's. Okay. The last one is Fisher's. Fisher said arithmetic mean is not correct. I will go for geometric mean. So it is the geometric mean of last year's and past year's method. So these are the 5 methods in the weighted aggregative method. First is last year's. Last year's L stands for last year, which means base year. So base year quantities are used as weights. You can see here base year quantities. Past year's P stands for present year, which is current year. So current year quantities are used as weights. Now Marshall Edgeworth combined both last year's as well as past year's. So both current year as well as base year quantities are used. Next, Dormish Bowley said arithmetic mean, whereas Fisher said geometric mean. Out of these 5 methods, the best method, the ideal index number is said to be Fisher's. Correct? This is about price index number. Now, quantity index number, I am not going to explain again because exactly it is same just like your price index number. Just that the difference is in the place of P, you will have Q. In the place of Q, you will have P. That's all. You can see here, it is summation Q1 by Q0 into 100. This is summation Q by N. Q is nothing but Q1 by Q0 into 100. Here also, okay. One thing we forgot to discuss, which is weighted average of relatives method. This is just like your weighted arithmetic mean. What is the formula for weighted arithmetic mean? It is summation Wx by summation W. Just like that, we have summation Wp by summation W. Again, P is nothing but P1 by P0 into 100. That's all. Got it? So everything remains same here. Instead of P, we have Q here. In the place of Q, you have to substitute with P. That's all. All these formulas you can construct using the price index number itself just by interchanging P and Q. Got it? This is the price index number. Next, value index number. Value index number is nothing but V01 is equal to summation V1 by summation V0. Value of current year divided by value of base year into 100. Now, what do you mean by value? Value is nothing but price into quantity. Okay. So, that's why it is summation P1 into Q1 divided by P0 into Q0. That is current year price into quantity divided by base year price into quantity. That's all, into 100. Got it? Next, consumer price index number. To find the consumer price index number, we have 2 methods. One is aggregative expenditure method. One more is family budget method. Now, this aggregative expenditure method is just like your last year's method's formula. How do you calculate the price index number as per last year's method? Same formula will come here. Got it? And family budget method is just like your weighted average of relatives method. This method which we just saw, it is this method itself. Same formula will be applied here. Got it? The first one, aggregative expenditure, is the last year's formula. The second one, family budget method, is the weighted average formula. That is summation WP by summation W. P is nothing but P1 by P0 into 100. Okay. Next. Coming to the test. Okay. Before test, we will first finish the balance topics. These are some of the important topics which we'll have to brush up properly. One is link relatives. What do you mean by link relatives? Always understand. See, price relative we calculate how? Current year by base year. Got it? Now, base year need not be last year. For example, 1995 can be the base year and today's, which is 2023, can be the current year. So, if I have to calculate price relative, I will compare the current year divided by base year. But for link relative, we always compare the current year price by previous year's price, immediate previous year's price. That is current year's price by previous year's price into 100. Got it? That is for link relative. Now, This chain index number, understanding this chain index number formula is important. This is one of the important formula you should understand. Link relative of current year into chain index of previous year divided by 100. Okay. Next, shifted price index. Shifted price index is original price index divided by price index for new base year into 100. Then we have a concept of splicing. So before understanding concept of splicing, what is the difference between shifting of price index and splicing? Understand that in shifted price index number, what happens is the base year is shifted. Let's say for example, 1990 was the base year. Today, 2023, where I stand, government felt that 1990 is very old. It is too old. I want to change the base year now. So, I will shift the base year from 1990 to 2000. This is shifting of base year. Because of shifting the base year, you will have to recalculate the index numbers. Those index numbers you calculate like this, which is shifted price index numbers. Got it? Where the same index series is going on, in that just the base year is shifted from one year to another year. That is shifting of base year. Because of shifting of the base year, I will recalculate the index numbers, which is shifted price index numbers. Okay. Now coming to splicing. Splicing means, let's say there will be two series going on. Say 1995, 96, 97, 98, 99, 2000, etc. One series going on. Second series starts from 2000, 2001, 2002, 2003 and so on. So there are two index number series. If I want to merge these series into a single series, that is known as splicing of index numbers. Okay. So index numbers, if I have to merge the two separate index numbers, that's when I go for splicing. Now shifting means in the same index number series, I am just shifting my base year from one year to another year. Understood? That is the difference between shifting and splicing. So in that we will have forward splicing and backward splicing. The formula for backward splicing is index A of current year divided by index A of common year into 100. Forward splicing is index B, that is index B series of current year by index A of common year into 100. What is the common year here? It is 2000. Here it ends at 2000, here it starts from 2000. I am combining the two series, which is known as splicing of index number. When I am combining, when I am splicing, see, understand, I will combine these two index series into one. That time, let's say I want to keep this as the base, 2000 as the base, which means that all these earlier, I will recalculate. That is known as backward splicing. When I'm merging, let's say I'm keeping this same, I will change this, which means I will recalculate all the numbers. This is known as forward splicing. So that's how you calculate using this formula. There will be one common year. Use that common year as the base and recalculate the values. Got it? This is splicing. Last we have is deflating. Deflating is as good as basically what we call is, deflation. Inflation means when the prices are increasing. Likewise, if your value is reducing, we call it deflation. So deflated value, how to find this? Take current value, the current year value as base, divided by price index of current year into 100. Got it? This is another important formula of deflating. So here we complete. Okay, the last one which is pending is test for adequacy, which means we'll have to now, this is purely a theory question. They can ask you a theory question based on test. There are 4 different types of tests. First is unit test. Unit test tells that the formula of the index number should be independent of the units of measurement. All you have to do is just remember which formula satisfies which test. This is what they can ask you as theory question. Okay. Now unit test, all the formulas satisfy except simple aggregative method. So except for simple aggregative method, all other methods will satisfy the unit test. Next, time reversal test. time reversal test says that when you are reversing the time, the answer should be the reciprocal, which means P01 into P10 should be equal to 1. Basically, your answer should be reciprocal. Only then you will get 1. Got it? This is what you should remember. Time reversal test says, now see, P01 means I am taking current year by base year. If I am reversing the time, base year by current year, my answer also should reverse. Only then I will get P01 into P10 is equal to 1. Now, which are the formulas which will satisfy this test? Only Marshall, Edgeworth and Fisher's. These are the only two which will satisfy. Laspier's, Ashes, Dormish, Bowley will not satisfy this test. Got it? Next, factor reversal test. Factor reversal test says P01 into Q01 should be equal to V01. Got it? P01 into Q01 should be equal to V01. Now in this, only Fisher is going to satisfy this factor reversal test, because Fisher satisfies time reversal, Fisher satisfies factor reversal. That is the very reason Fisher's index number is known as ideal index number, because even though the other formulas don't satisfy, Fisher's formula will satisfy these tests, which is time reversal test as well as factor reversal test. Last we have a circular test. Circular test says that when you start from one particular year, you could end up coming to the same year. For example, you start from P01, you go to P12, P20. You start from 0, you come back to 0. You should get the same answer. Basically, P01 into P12 into P20 should be equal to 1. Got it? So in time reversal, just two periods were involved, which is base year and current year. In circular test, you have third year, one more year, which is 2. Got it? 0, 1 and 2. It should come to the basically the starting point again. This is the circular test. All this just to remember from the theory question point of view. They are not going to ask you anyway descriptive. It is purely MCQ. So all you have to remember is what do you mean by every test and which formula will satisfy what test. That's all. The last one, circular test, is only satisfied by two formulas. One is simple average geometric mean. One more is Kelly's. These are the only two formulas which will satisfy the circular test. Okay. This is the end of the chapter, index numbers. Very simple chapter. All you have to do is just by heart the formulas of price index numbers, value index numbers and quantity index numbers. Then one more type of question which can be asked is based on the test for adequacy. Which are the formula which will satisfy what test? That's all. And the last is few extra concepts are there. Deflating, slicing, shifting. All these are also important concepts. Okay, all you have to do is just remember the formula. So now I think we have covered all the chapters. Index number is done. Correlation, regression is done. Theoretical distribution is done. Probability is done. Measures of central tendency and dispersion is also done. So now we only have last chapter, which is actually a theory chapter. So I don't want to get into the details of this chapter because it's purely theory. No matter how much I explain, you still have to end up studying. So I'll just take 5 minutes and quickly brush up what is important, what is what. That's all. Okay. Now, just because this is theory chapter, don't make the mistake of skipping this chapter because at least 6 to 8 marks you can actually expect from this chapter. So, statistical description of data. What is important is one thing. See, data can be what? Variable. It can be attribute. Now, variable, what is variable? Variable is any data which is quantifiable, which is measurable. And attribute is basically the qualitative feature, correct? Such as gender, nationality, color of the eyes, etc. All these are what? Attributes. Now coming to data. The data can be of primary data, it can be secondary data. What is primary data? Primary data is a data which the investigator collects for the first time, correct? But if the data which is already collected is used by some other person, that is secondary data. For example, census. You are collecting the data from the census report. What is that data? It is primary or secondary? So census data is basically you are collecting from the census report is the secondary data because you did not do the census, right? Which the government has already done the census. Now you are just using the data which is from the basically the census report. Okay. So you are using the data which is already collected by the government, and that is why it is the secondary data. Now primary data, there are different methods. It's very important. You can read this in detail. One is interview method. In interview method, again, there are three types. One is personal interview method, basically direct interview, indirect interview, and telephone interview method. Second method is mailed questionnaire method, where a set of questions are sent and asking them to fill up. Next is observation method. For example, if you want to check the height and weight of the students, you bring a particular weighing scale to get an instrument and you check their weights. Correct? So that is what observation method, where you yourself using some particular instrument, you are collecting the data. It is observation method. The last one is questionnaire, which is filled and sent by enumerators. These are the four methods of collecting the primary data. Next, secondary data, you have two sources. One is published sources, one is unpublished sources. Now, before you just rely on the data which is collected, you go for scrutiny of data. It is very important to look for accuracy, whether the data collected is consistent, whether it has basically whether it is accurate and whether it is consistent. These are the two things you have to check in the scrutiny of data. Next, coming to classification of data. Now, before you present the data which you have collected, you have to first classify them. If you are classifying them based on the time, we call it chronological data. If you are classifying them based on the region wise, it is geographical data. If you are classifying them based on any variable, it is quantitative data. If you are classifying them based on attributes, it is qualitative data. For example, based on gender, it is attribute, correct, which is qualitative data. Next, presentation of data, again very important. Textual presentation, tabular presentation, diagrammatic presentation. Very important is, see, understand, textual is the most boring method. The most attractive method is diagrammatic. However, the best method and the most useful method is what? Tabular method. Tables are always the best. They are more accurate when compared to diagrammatic also. Got it? But if they ask you which is the most attractive, it is diagrammatic. Best method, tabular method. Okay. So one more thing you have to read properly is the contents of the table, which is stub, caption, box head, footnote, body of the table, etc. All these are important. Then different types of diagrams. You have line diagram, bar diagram, pie chart. Very important to understand which line diagram is used when. For example, simple line diagram is there, log or ratio chart is there, multiple line diagram is there, multiple axis diagram is there. All these you have to understand in which scenario what line diagram is used. Very, very, very important. Okay. The next is bar diagram. Bar diagrams also, there is simple bar diagram, multiple, subdivided, percentage. All these also you have to read very carefully. For what situation, what type of bar diagram will be used. This also can be asked as theory question. Next, coming to the second part of the chapter, which is based on frequency distribution. All these you already know, which is very simple. Frequency distribution can be simple or ungrouped. It can be grouped. Okay. Next, frequency distribution can also be univariate, can be multivariate. Now, few important terms. Class intervals are what? It can be inclusive class intervals. They can be exclusive class intervals. Class limits are what? Lower class limit, upper class limit. Now, this midpoint which we calculate during the arithmetic mean calculation, that mid value is also known as class mark. So, in the question, if they ask you what is class mark, it is UCL plus LCL by 2. That is nothing but the midpoint itself. Okay, this is important. Next, class boundaries. That is the upper class boundary, lower class boundary. Class width, I told you, don't forget this size of the class interval, width of the class interval, length of the class interval. Same formula, which is UCB minus LCB. Okay. Then we have cumulative frequency, that is less than type cumulative frequency, more than type cumulative frequency. These two formulas are also important. Read this carefully. Relative frequency, frequency density, both these are important. Next, last topic we have is graphical representation of frequency distribution. In this we have histogram or area diagram. What is important to understand is which diagram can be used to find what. Now, for example, histogram or area diagram can be used to find mode. They will ask you a question. Which diagram is used to find mode? Mode can be calculated using dash diagram. That is histogram or area diagram. Next, frequency polygon. Then we have ogives. Ogives we have less than ogive. We have more than ogives. Ogives are used to calculate median. So understand, not just median, also they are used to find quartiles. Got it? And last we have is frequency curve. Frequency curves are roughly hand-drawn curves. There are 4 types. One is bell-shaped curve, U-shaped curve, J-shaped curve, and fixed curve. That's all. This is all about your chapter statistical description of data. The theory looks huge, but trust me, when you study like this, when you concise everything and study, it looks very, very simple. Don't make the mistake of skipping this chapter. I'm repeating again and again because 6 to 8 marks can be expected from this chapter generally. Okay. So all these questions which I have told you, important ones, please don't skip these topics. Read them very, very carefully. Got it? So here we complete the wonderful session on statistics. All the 6 chapters have been covered. So because it is already 20th, you have just 10 more days left. Don't panic, students. All you have to do is just give your 100% efforts. That's it. Okay, the rest will follow. Don't worry about the results. Just focus on giving your best. And when it comes to how to approach this particular paper, the quantitative aptitude, remember the easiest one generally will be logical reasoning questions. So first finish the questions on logical reasoning, then proceed to maths or stats, whichever is easy for you all. If it is stats, then start with stats. In stats also, you will have difficult questions, easy questions. First, go on solving easy questions. Once that is done, then go for maths. In maths also, whatever easy questions are there, go on solving. So at the end, you will realize that at least 40 you would have scored. So once you know that you have scored 40, you will pass that particular subject. You will start getting the confidence. Then start approaching the difficult question. Every single question will give you bonus points. Correct? And one more thing, because you have negative markings, please don't guess the answers. Only if you are confident about any particular question, only then go for the answer. Okay? Because there is negative marking, don't lose your marks simply. All right. So study well. All I would say is all the very best. It was a wonderful session interacting with you all. You all have been very, very interactive and nice. So before we wind up the session, all I would like to say is all the very best. Do well. I hope to see you all on the other side. Let's say inter. Okay. So let me know how the session was in the comments. So all the very best, students. See you.